Hey guys, this looks like a fun one. We are given 5 equilateral triangles. The largest one has an area of 14, and the question is asking, what is the total area of the other 4 triangles? If you want to try it on your own, pause it right now because I am going to solve it in 3, 2, 1. Since we are dealing with equilateral triangles, we should use these notes right here. They give us the height of the triangle in terms of the side length, and also give us the area of the triangle in terms of the side length. But now that I am thinking about it, do we really trust these notes? How were these notes made? Let's see if we can figure this out ourselves. Let's start with an equilateral triangle, and let's call each of the sides S. Let's draw the altitude of the triangle, which will be at right angles, and let's label it H for height. This altitude cuts the base in half, so each of those two parts has a length of S over 2. Now let's focus on this right triangle and apply the Pythagorean theorem. We have S over 2 squared plus H squared equals S squared. That S over 2 squared means the square goes to both the top and the bottom, giving us S squared over 4. Next, subtract S squared over 4 from both sides. On the left-hand side, we are left with H squared. On the right-hand side, S squared minus 1/4 S squared is 3/4 S squared. Now, to get h by itself, we take the square root of both sides. Since h is a positive distance, the square root of h squared is just h. On the right-hand side, each part under the square root can get its own square root. The square root of 4 is 2. The square root of s squared is just s. So we find that the height of an equilateral triangle is exactly square root of 3 over 2 times the side length. Now let's use this to find the area. The formula for area is 1/2 base times height. The base is s, and the height is square root of 3 over 2 times s. Multiply it out. 1/2 times square root of 3 over 2 is square root of 3 over 4, and s times s is s squared. So we have the area is equal to square root of 3 over 4 times s squared. Perfect. We just derived the notes ourselves, so now we can trust them. Next, let's call the side length of the largest triangle x. Let's call the side lengths of the 3 congruent green triangles y. And let's call the side length of the yellow triangle z. Using our formula, the area of each green triangle is square root of 3 over 4 y squared. Since there are 3 of them, their combined area is 3 times square root of 3 over 4 y squared. The area of the yellow triangle is square root of 3 over 4 z squared. So the total area of the 4 inner triangles is square root of 3 over 4 times the quantity 3y squared plus z squared. That's the expression we need. Now let's go back to the largest triangle. Its area, which is 14, equals square root of 3 over 4 x squared. That's another important fact. Now we need a relationship between x, y, and z. Look at this right triangle inside the diagram. Its hypotenuse is x. The base is cut into 3 parts. The first part is y, the second part is y over 2, and the last part is z over 2. The vertical side is the difference of the heights. The height of the yellow triangle is square root of 3 over 2 z. The height of the green triangle is square root of 3 over 2 y. So the vertical side is square root of 3 over 2 times z minus square root of 3 over 2 times y. Now apply the Pythagorean theorem again. After simplifying all the terms, the cross terms cancel, and we are left with 3y squared plus z squared equals x squared. That is beautiful because 3y squared plus z squared is exactly the piece we needed for our total area formula. So the total area of the four inner triangles is square root of 3 over 4 times x squared. But wait, that is exactly the same as the area of the largest triangle, and the area of the largest triangle is 14. So, the total area of the four smaller equilateral triangles is also 14 square units. And that's the answer. The combined area of the four smaller triangles is the same as the area of the largest triangle. Guys, if you have still not subscribed to my channel, subscribe it now and never miss an update.